Ceramic components are everywhere around us, from space exploration to energy production, even in our homes and cars. Our experts guide you through the basics of engineered ceramics, from how they're made to how they're applied. I'm Scott Thompson, R&D Manager here at CoorsTek. Welcome to Ceramics 101. We begin with, what is ceramic?
Ceramic.
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 The word ceramic comes from a Greek word, keramos, which is derived from a Sanskrit word meaning burnt. But if you want to get technical about it, a ceramic is an inorganic, non-metallic, solid material held together by ionic or covalent bonds. What that means is ceramics are typically hard, stiff, wear-resistant, and chemically stable. The beauty of ceramics is you can formulate them to be whatever you want them to be. And that's what we do here at CoorsTek. We call them engineered ceramics.
When metals and plastics fail, you need to look to more advanced materials to solve your problem.
There is a special, say, blending of ceramics to get the right hardness or the chemical resistance, the electrical conductivity.
We truly engineer on a molecular basis to assure that the property demands are going to be met for applications throughout industry.
There's engineering that goes into the materials, but then there's also engineering that goes into the forming and the firing and finishing of the process.
It's industry that's constantly clamoring for new materials. Why? Because they keep destroying the old stuff. They need materials that are going to be better. They need materials that are going to be tougher, stronger, and really engineered ceramics lead the way in these marketplaces.
You'll find ceramics in nearly every industry in the world. That means the house you live in, the car you drive, the machine or computer you work on have all been made possible in one way or another by ceramics.
We make parts for medical field. We make parts for the computer field.
Motor parts, interior light parts.
Everything from electronics to car parts to military stuff.
When you go to a convenience store and get a soda out in a cup, we make the valves that meter the syrup and the water.
It's not something you're going to buy over the counter, but it's a product inside of a product inside of a product.
Before we close out this first lesson, let's talk a little bit about the properties that make ceramics ideal materials for harsh applications. We can break this down into four main areas: mechanical, thermal, chemical, and electrical. By controlling the mechanical properties, we can affect hardness, strength, and toughness. Our ceramic body armor plates are formulated to be nearly as hard as diamonds. Thermal. A ceramic can either conduct more or less heat, or operate at high temperatures. The ceramic substrates we make for circuit boards are formulated to absorb and dissipate heat from electronics. Chemical. Some parts require corrosion resistance, like beverage valves. The beverage valves we make resist chemical corrosion from acids in soft drinks. Electrical. We can design our parts to either be insulators or conductors of electricity. Electrical insulators you see on power lines stop the high voltage from electrifying the towers they're on. Ceramic production is all about creating the right mixture of materials that makes the ceramic part do exactly what we want it to. Think of it like cooking. Add all the right ingredients, cook at the right time and temperature, and you get the desired outcome. That's it for this one. In Lesson 2, we'll learn how all those ingredients combine to make the powder base for our ceramics. See you then.